Hi everyone. I think we can get started now. Today I'm going to be talking or listing some resources for math, and that's mostly going to be books. So to start off, um, one kind of category of books that are useful for preparation for competitions are problem books, and basically they have most of the ones that I've listed are just like compilations of past problems from different contests. So there's Math Counts, and then the MOEMS contest, Math League, Mandelbrot, ARML, and then also AMC contest problem books, which I think are not as necessary because Art of Problem Solving already has like all of the problems and most solutions for past AMCs and AMEs and everything. But yeah, so think I don't think most of these are free, because I guess books are usually you have to buy them to get access to them. But if you do find yourself like running out of problems to do or something, then these could be good options. And most of these are for middle schoolers. Some of them, like Mandelbrot and ARML, definitely are a little bit more into like high school math. But yeah, these are some of the good ones, I guess. Um, the next category, I guess, is art of problem solving, which just has a lot of resources. So for books, they have like volumes 1 and 2, which are kind of general and they're used for contest preparation. And then also they have the intro series and also intermediate and advanced books. So they have algebra and combo. And they also have like pre-calc and calc. Yeah. And then competition math for middle school is also a book from AOPS, but it's specifically geared toward competition math. So I guess they might have like example problems that are more competition-y. And then the last 2 points are not books, they're just sites on AOPS. For the Win is more, I guess, for fun. It's like Countdown where you do problems really quickly, but you can play with your friends or just random people on the internet. And Alchemist is actually, I think it's a really good uh, resource. Basically, they have a bunch of problems and they show you like the different topics that you can study. And then you just you put your answer in when you're done and they tell you when you're wrong. But it's nice to kind of see like the progress that you're making because they have little graphics marking it. Yeah. And then the next one is for high school math. So that's going more into AME and then later on proofs in Olympiad problems. I've already mentioned some of these in past weeks, but there's EGMO, of course, for Geo. And then problem solving strategies is a little bit of an older book, but it's really good and it has a ton of problems and also like introductions or just lessons basically about different topics in the chapters themselves. So it's not just problems that you can solve. Same with EGMO. And yeah, there's like very many problems, so you probably won't get through all of them. But I think kind of just going through a few of them for each chapter will give you an idea of what you might need to work on more. And also, another book that I have read and gone through is The Art and Craft of Problem Solving by Paul Zeitz. That one's really good. Paul Zeitz is one of the co-founders, I think, of BAMO and Proof School. But yeah, the one that I have gone through actually had like lecture videos included in it. So it was the book, but it also had videos to accompany the problems where like Dr. Zeitz explained some of the exemplary problems, I guess, from the chapters. And that was really helpful. I think like just having someone explain to you, even if it's through a video, is much more engaging and it's a really fun way to learn. But that also probably costs money. So the book itself is very good and it has a lot of problems that can be useful to building for building a good foundation in Olympiad problems. Yeah. And then the next one is how to read and do proofs. Pretty self-explanatory. Also, MAA Press itself has released a book called A Gentle Introduction to the AMY, and I remember kind of working through it. It has some explanations and solutions for the AMY problems, and generally, I guess, helps you organize a little bit more in your brain, like the different topics that you should pay attention to. Also, there's challenging problems in geometry and algebra. It's what it sounds like. And then Awesome Math, or the creators of Awesome Math, have have published a lot of books through XYZ Press. This is a screenshot. But if you just search up Awesome Math books, and this applies to all of the books I've listed already, like if you search up the name, you'll probably get to where I am referring to. But there's actually a file online somewhere that shows you like literally every single publication that they have. And a lot of them are called like 100 and something problems in blah, 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 like algebra or polynomials and so on. So yeah, those are pretty cool. They have explanations as well, so it's not just problems. But yeah, okay. And then the final slide is something that's a little bit different. It's less of like learning how to do math and more kind of cultivating an interest in mathematics beyond, I don't know, just like doing problems or like reading in a book or like watching lectures. Um, and there's a lot of books and movies and media in general that use math and use ideas from mathematics that are really interesting. So Flatland is a book, but it's also a movie. You can check it out. Alice's Adventures in Wonderland, or just Alice in Wonderland, also has a lot of math topics in it that maybe you might not pick on or pay attention to if you're just watching it for enjoyment, I guess. There's also the other ones that I've listed, like The Curious Incident of the Dog in the Nighttime, which actually has like a maths appendix at the end, which is pretty cool because the main character in the novel really loves math and he thinks that it's really cool because as he says, there's always an answer, which is not technically true because there's a lot of open problems. But I think that it's cool that he takes comfort in mathematics. And yeah, there's a lot of interesting problems in there. The Joy of X, Zero, which is about, I guess, the invention of zero as a concept, which is interesting because we kind of take it for granted, like the existence of zero, but it's like it's the bridge between the positive and the negative numbers. And when it was first introduced, it was a very revolutionary idea. And as the title describes it, actually dangerous. So yeah, That one's pretty interesting. And then also How to Lie with Statistics um, is a cool title, but it also teaches you about statistics itself. And then the second part of this list is movies or kind of documentaries. Actually, yeah, these are not documentaries, these are just movies, but they follow the life of some mathematician or physicist or, yeah, someone who works in like physics and science. The Man Who Knew Infinity is really interesting. It goes through the backstory and the life of Ramanujan, a very accomplished, who was a very accomplished number theorist. And yeah, I guess it's a really inspiring story of how he came from like very humble roots and then made all of these wonderful contributions to math. The Theory of Everything is about Stephen Hawking. A Beautiful Mind is about John Nash, who created the Nash equilibrium in economics. It's also kind of a heartbreaking story of like how his mind deteriorates. But anyway, The Imitation Game is about Alan Turing, who created, he's described as like the father of computer science. And yeah, he created like one of the world's first computers. It looks very different from the ones like that we have now. But yeah. And then Hidden Figures, which I think probably more of you know about already, but it's about three women who worked at NASA and sent the first person to orbit the Earth. Um, yeah, into orbit. So yeah, I think books and movies and media like those are just really cool ways to learn more about mathematicians and also how math could apply in your lives or in these books themselves. So that's it for my presentation. It was pretty short because I guess I'm just listing a lot of resources that you can use. But as always, if you have any questions or clarifications that you would like, feel free to ask for the rest of the hour. So yeah, I don't know if you were here at the near the beginning of the meeting, but I would say if you're trying to prepare for AMC 10, the very first thing that I would suggest is just going through past problems. But beyond that, I would say I think if you have them, maybe going through like some of the AOPS books that are focused on like the the subjects that you think need more work. Um, I think also that there's probably lists online about like the different topics that you actually need to know for AMC 10 and also for AMC 12. So you could probably look into that to see like what I guess you're looking for. But yeah, as I said before, AOPS has like introduction to algebra, accounting, and probability. And then after that, you can also look at intermediate algebra and intermediate combo. Um, I don't think they have like too many geometry topics on there. It's mostly just like areas of shapes and maybe a little bit of like similar triangles and things. Um, yeah, so I would say maybe also the book Competition Math for Middle Schoolers. And I don't think that there's a certain order that you should probably go through like these materials in because I don't know. I think that maybe like competition math for middle schoolers or just like competition prep books in general, you could go through a little later because you want to build the foundations for the topics or the concepts themselves first. And the AOPS books and other books like it can help with that. And then once you get a little bit closer to the competition, maybe you could go through kind of like more general synthesis type books. Um, for AMC 12, I think that I don't think there's like a very big difference between how you should prepare for those two. And I would actually recommend like looking at AMC 12 problems to prepare for the AMC 10 because it'll make them seem easier and you'll like learn more, I guess, that way. Um, for AMC 12, like once you get to looking at those topics, the only things that they add are like logarithms and complex numbers. I'm pretty sure that's it. Uh, yeah. So, I don't think you need to get books on like those topics specifically. You could probably just look online for resources on that. Hope that helps. Okay. And then another question about, I guess, improving scores on Amy, like year to year. Um, yeah, I think that you've already made a lot of progress and that in order to improve scores on Amy, um, if you're like at this level, I think that focusing on like 6 to 10 and then kind of looking at the last 5 problems to see if there's anything that you have any ideas on is the most effective way to improve from here. So, for Amy, let's see. I think the intermediate books for AOPS would definitely help. And then, um, for me, as I mentioned before, like MAA's book, A Gentle Introduction to the American Invitational Mathematics Exam, was really helpful because they give you the Amy problems themselves, but they also like separate it into the different concepts that they focus on in each problem. So I think that would be a really good way to improve your score. I would look at it. I'm looking at it right now, but yeah, so there's like different sections and you can definitely pick and choose. I think they have, yeah, they have like combo in general and then probability, number theory, sequences and series, logarithms, complex numbers, and then different types of geometry. So I think that like picking and choosing the chapters that you would like to focus on. And that applies to any book that you decide to like look through a little bit. Um, but yeah, picking and choosing those, and then just going through like their explanation and their introduction of the concept itself, and then like right after that, applying what you just learned to the problems themselves is really helpful. So I would also say that like when you're looking at the problems, if you don't know how to do it, you can definitely look at the solutions that they provide. But I think people probably stress this a lot. Um, but like really understanding the solution and going through it in depth and seeing like what you could have, I guess, thought of to be able to get to that solution, or like kind of being able to summarize the crux or the most important part of that solution, like the most important insight that you would need to get to. And then, I don't know, I guess just keeping that in mind for the rest of the problems that you do. So, yeah. Um, how many hours do I spend on math? I think I've answered this question before, but like it definitely depends on what time of year it is. Like depends on what type of math I'm like preparing for, when the competition is, and all of that. Um, like if I'm preparing for AMCs, it'll probably be, since like once you've learned those topics already, it's mostly going to be just problems, doing problems and like understanding the solutions to them. And I think that once you get to like a higher level of comfort or familiarity with those problems, you only need to spend time on like the last few to really hone in your skills. So yeah, for AMC, I would probably only do like a few sets of 5 a day or something, like the last 5 problems. And then for Amy is like the same thing, maybe the last 5 or like 5 to 7-ish problems. Um, I would probably just do 1, maybe 2 on the weekends a day. And then once you get to Olympiad math, I would say it definitely is kind of more difficult to figure out how to spend your time preparing. But yeah, I think for Olympiad math, there's also a like widening of the types of things that can show up. So I would probably spend like a little bit of time reading on like a new technique, I guess, if I have one that I've seen and like didn't know. Um, and then just, I don't know, working on a few problems and then doing solution review. Yeah. Right now, since like I don't think there's any math competitions very soon, since it's like the end of the year, I'm not doing very much every day. Oh, also, I think that really also depends on like the person. What works for me definitely does not have to work for anyone else. So, yeah, I think that like figuring out how you prefer to study and practice math is also really important. And it'll also make you, I guess, like it more and have more fun, rather than limiting yourself to like, this person does this, so I should. So Is this a question for preparing to qualify for USICA Gold or like preparing for the USICA Gold contest and working on a promotion to Plat? Okay, so you've already passed silver. Um, okay, so I am not sure if I would have the best answer to that. Um, I think I think I could probably like invite someone in the future who has more expertise because I'm also in New School Gold. But I would say definitely like looking at the at Musical Guide. It has all of the topics that you need to know, and it also says like how often they show up, and how likely they are to show up on contests. So yeah, it's a really helpful resource. I used it for silver and I also have used it for gold. They have like explanations and they also give examples of the problems that use those ideas in them. Also, I think just having a very solid understanding of the algorithms that you need to know, like at their most basic level, and also being able to like put modifications on them as needed for specific problems is really important. So like I have files for just the most bare bones versions of different algorithms, like the graph algorithms, like Dijkstra and other shortest path stuff and like minimum spanning trees and things like that. But also like really understanding what exactly is going on in those so that you know how to change them around for like accomplishing what the problem is asking you to do. Yeah, I don't know. I think that like once you've learned those concepts, it's really a question of like how well you can implement them without errors and also, of course, like being able to debug. So I think exposure to a lot of problems that use those topics is really important because you never really know like what new way they're going to come up with to frame like what you've learned in. Um yeah, so I think you should probably like look through how past contests have in a way like disguised what they want you to do. And then also I think that like they used to call gold and also silver and bronze contests are getting harder and that's just kind of how competitions in STEM usually work. So they are probably like combining topics a lot more, so being prepared for that too. But yeah, I hope that helps a little bit. So for me, um, I think, well, I took the like the Alpha Star classes and I thought they were pretty good, but I also think that I took them at like when I was, I don't know, I think the timing that I took them at was not that great. But if you're taking the classes that are right for you, I think that could definitely help. Um, yeah, I don't know. I don't know how much better than like just studying on your own would be, but their booster camps in particular, I think, are pretty helpful. They're designed to like help you increase your score so that you can qualify to the next level. So I think that those classes I would say are better than just like the normal ones for like year round. Um, I also took X Camp, and that's where I learned about a lot of the algorithms. But as I said before, like I think that you can definitely learn those on your own if you want, and I don't think there's a huge need to join a class for that. For resources, yeah, I'm not sure because I think the one that I've used most is just the use of code guide because it's already pretty comprehensive and really helpful. There's also a lot of like videos online explaining solutions and concepts themselves. So I think that that could be a good resource. So I think that if you're only getting part of the points, one possible reason is that you're timing out for the rest of them. And that just means that you're probably not using the right algorithm because it doesn't have a small enough like O time thing. Um, but if the rest of the cases are all just wrong, like they're not timing out, but you're getting the wrong answer, the I think like what's really important as a skill to develop is being able to come up with your own test cases. And it doesn't mean you have to be like super creative and I don't know, like make really weird things, but just being able to come up with new like test cases to test your code against that you can find the answer to easily by yourself, and check that against what you get is really going to help you because like when you get something right with your code, that doesn't really tell you too much. But when your code, like you give it a new test case and it gives you something wrong, then you can go in and debug and see what exactly is going on, like what are the variables at each time, and then really figure out like what your code is doing and what it should be doing. Um, and I think that that will give you the best idea of how to fix your code. I think improving, like being able to get everything in one try is really hard, but most people probably like the first time that they submit their code to like a particular problem, they're not going to get all of the points. And if you want to like improve your accuracy, so to speak, I think that really does come with experience and like being able to understand all the edge cases if there are any, and kind of just having like a clearer understanding of what you're putting into your code as you're writing it. Like, what are you actually telling the computer to do, if that makes sense? But yeah, I think the most important thing is like developing that skill to make your own test cases. And once you can do that, you can just test like a bunch of them against your code as opposed to the one or two that you get in the problem statement. I did not take any classes to prepare for AMC 12 in particular because, well, I just took AMC 10 until I was in 10th grade. So this was the first year I took AMC 12. And to prepare for AMC 12, I obviously did the problems themselves from past years. Um, I guess last year and this year, I also took Dr. Nell's course, which was more for like Olympiad. So I don't know if that was really super helpful for AMC 12, but I guess in previous years I've taken Amy classes from the same place, Alpha Star, and those cover some of the topics that are added to AMC 12 from AMC 10, so like complex and logs. So that probably helped a little bit, but I think, yeah, once I got to like Amy, which is definitely a much longer test, the biggest concern for AMC 12 was like being able to go through the problems on time and have enough time to look properly at each one. So, mostly to prepare for that, I just did practice. Yeah, I took, um, I think it was 702A is the course name, but it's an Olympiad course, so it's not AMC 10. I just mentioned it because I was like taking that course during the time that I was preparing for AMC 12. Yeah, so I think that's it for today. Hopefully, I answered most of your questions. And yeah, thank you for coming.